So in order to prove that triangles are congruent, back in the day, you used to have two triangles, and you had to show that you had 1, 2, 3 sets of congruent sides, and 1, 2, 3 sets of congruent angles. So that was 6 things you needed to know in order to prove that the triangles were congruent, that they had the same perimeter, the same area. So now we have some shortcuts. The shortcuts include 2 to 3 minimum facts you need to know in order to say that the triangles are congruent. The most basic one is side, side, side triangle congruence. That's saying if you have two triangles, okay, and these are poorly drawn triangles, but you have two triangles, and you only have the sides marked. So if I only have these 3 facts, I only have 1, 2, 3 sets of sides that are marked congruent to 3 other sets of sides, then I can automatically say that the triangles are congruent. Once we're done with that, then we can say that these corresponding parts are also congruent. So that means the angle between the 1 and the 3 is going to correspond and be congruent with the angle between the 1 and the 3. The angle between the 1 and the 2 is going to correspond to the other angle between the sides marked 1 and 2. They're also going to be congruent. And then my third angle is going to be congruent to my third angle. We say this is corresponding parts of congruent triangles are congruent. I'm much too lazy to write it out, so that's the reason. The next type of triangle congruence is SAS. I guess they're not really in any order, except for that the angle that is congruent is between the 2 marked sides. So this is saying there's no other triangle I can make if I have a specific length of 2 sides and the angle between them. There is no other triangle I can make to connect these 2 sides. The third side will always be congruent, and then those other 2 angles are also going to be congruent. So if this was x and this is 5, we know x equals 5. If this is 30 and this is 2y, let's change the letter. Then we know, because they're marked congruent, we know that 30 equals 2y, so 15 equals y. Another type of triangle congruence is angle, side, angle. This means if I have the same situation where I have 2 angles marked congruent and side in between them, there is no other different set of sides and angles that would make up a different triangle. So obviously I can't change this angle right here. I can't change this angle right here. And no matter what, this second and third side are going to be congruent, and this third angle is also going to be congruent. And then the last type is angle, angle, side triangle congruence. Oops, and my drawings are getting worse. Okay, so I have 2 angles marked, and then the side, it's not in between the 2 angles. So I have 2 angles that are marked congruent in one side to 2 angles marked in one side, marked congruent. So once you see a picture like this, then you automatically know that these triangles are congruent, so that third angle, if that third angle was 30 degrees on the left triangle, then I know automatically the third angle, even though it's not marked, is also 30 degrees. If that right side is 15 on the left triangle, I automatically know that the right side is going to be 15 on the right triangle. So let's practice this. Again, there were 4 types of triangle congruence. There was the one we just finished, angle, angle, side, angle, side, angle, side, angle, side, and then side, side, side. And side, side, side is really an important one because whenever we have right triangles, side, side, side becomes even easier. If you're given the hypotenuse in one leg, you know you can use Pythagorean theorem with a right triangle. And no matter what, let's say this was 5 and this is 4. If I were to do Pythagorean theorem, what's this third side going to be? 3, right? So there's no way, if I'm given a hypotenuse and a leg of a right triangle, there's no way that the third side is going to be anything different. So if you ever have a right triangle, you could just use the reasoning that the hypotenuse and leg of one triangle are marked congruent to the hypotenuse and leg of another triangle. These are basically the same thing, but you wouldn't have to do Pythagorean theorem. So let's practice. Okay. Oof, that's a bad picture. I'm trying. Okay. Are these triangles congruent? No, right? Because they're totally different side lengths. Are these triangles congruent? Well, we have a side and another side and an angle. But let's think about the order that it goes in. On the left triangle, I have 2 sides and that angle is not in between them. On the right triangle, I have 2 sides and that angle is not in between them. Is that one of the 4, 5 possible ways? No. So these are not congruent. Or, I mean, they could be, we just don't have enough information. Are these congruent? Yes. What type of congruence do they have? Well, if I'm just looking at this top triangle right here, it has 2 angles marked and nothing else. But I notice that both of the triangles share this common side, and that side is between the 2 angles. Now if I look at the bottom triangle, again it has 2 angles that are marked and the side in between them. So since they're both the same, they are congruent, yes, by angle, side angle. Okay, so let's look at this one. Are they congruent triangles? Yes or no? Well, we only have 2 markings. I have a side, and then I have this little arrow thing. So remember, whenever we have arrows, we can think of parallel lines and transversals. So I can think of these 2 parallel lines and a transversal, which means I have alternate interior angles. Another thing you can think of is whenever you have lines that intersect, any lines that intersect, no matter what, doesn't have to be parallel, you're going to create vertical angles. So in the top triangle, I have 2 angles marked and a side, and that side is between them. On the bottom, I have 2 angles that are marked and the side is between them. So this is congruent by angle, side angle.